Hi everybody. In this video I'm going to show you how to make a very simplified version of the game Pong. You can see there's a player controlled paddle. The ball bounces off of the edges of the screen and off of the paddle. It's just keeping a score by giving you a point as long as you don't miss the ball. So you're not even playing against another paddle, you're just trying to not get scored on. And then eventually, over time, the ball gets faster, and when you miss the ball, the game's over. So it's a very simplified version. It doesn't have another paddle to play against, and there's really just a paddle, a ball, and basic scorekeeping. So this should be a good introduction to using Pygame to create games in Python. Before I do that, because most of these videos up to this point have explained, have been using Replit, browser-based editor. I'm going to use idle because idle just tends to display Pygame games much better, and it's much easier to work with when using Pygame. So I'm just going to show you how to get started with idle and also how to install Pygame. So the very first thing you should probably do is just go to PowerShell and type pip install Pygame to ensure that you have Pygame installed. I already have Pygame installed on my machine, and if you do, you'll get this message too. It says what version of pip you're using. Which version of Pygame you're using. Requirement already satisfied, Pygame in, and it says where you have it should say where you have Pygame installed. As long as you have Pygame installed, you should be good to go. So next, I'm just going to make sure I have idle configured the way I want it. So IDLE is just the sort of default IDLE. See, is the default Python editor. So if you have Python on your computer, you definitely have idle. And I'm just going to configure a few things. First of all, in configure idle, I'm going to increase the size a little bit. I'm going to make this I'll make this even larger than necessary so that it is easy to read for the video, but you can set the size however you want. And under highlights, I'm going to choose idle dark. Apply and click OK. So obviously you don't have to make your font this large. I'm just making it this large so that it's easy to read on the video. But you can set the size and the the theme to whatever you want. And then I'll click File, New File. This is where I'll be doing my editing. And for my options for the file, I'm going to click Show Line Numbers. This is going to be really helpful for any debugging because the error messages will frequently tell what line number the error occurred on, and makes it much easier to debug. So now that stuff's all set up, let's go ahead and get started. The first thing I'm going to have to do is just a bunch of Pygame sort of basic starter code, just sort of stuff that needs to happen, some import statements and things that just have to be there in order for anything to happen at all in Pygame. So I'm going to import sys, and I'm going to import Pygame. And I'm also going to do from Pygame.locals import star. It'll just import all from pygame.locals. And there are a few things that need to happen in order for Pygame to do anything at all. One of those is pygame.init to start up Pygame. Another is setting up an FPS clock. I'm going to define my screen width and screen height as 640 and 480. You might not have seen this this notation before, so I could define these separately. I could say screen width equals 640, screen height equals 480, and this would work just fine. But you can also, if you have a number of related variables that you're setting up, if you're declaring variables that are related, or you just want to get a few variable declarations out of the way, you can put them on the same line with a comma separating them. And make sure that you include both sets of parentheses here. Pygame.display.setMode, which is going to set up the screen that this game will be drawn onto. It takes one argument. So the inner set of parentheses is a tuple or a list. It has to be some screen width, comma, screen height, double parentheses. So this, we just cut this out for a minute. This takes one argument. So I need to put a single item in here. And the item in this case is it could be a list or a tuple. In this case, a tuple, which is just an immutable list. It could be a list as well. Either one works, but that just is because it accepts the width and the height as a single argument instead of as two separate arguments. So you have to group them together like that. And then in order to keep the screen up and running and do all the things that are going to be done, we need to have a while loop that's just going to always be running as long as the game is running. And then inside the while loop, this is where most of the game is going to happen. Anything that runs during the game is going to happen inside this while loop. So I'm always going to, if I want to, I'm always going to have to fill, the first thing I'm going to have to do is fill the screen with my background color. I'm going to say screen.fill, and I could, again, as a tuple, so I could manually enter my colors as RGB values. What I'm going to do instead is define some variables for the colors, or really define some constants. So in Python, there isn't actually a difference between a constant and a variable. So just by convention, constants are set up. Constants are just declared with all caps for the variable name. So in this case, I want black to be defined as 0, 0, 0. So it's just the RGB values for black. If as we go on, I'll be defining more colors. If you want to use different colors than the ones I'm using, not what I meant. If you want to use different colors from the ones that I'm using, you can use a color picker on the internet. Just do like Google color picker and choose the color that you want. Maybe you want some shade of green, or particularly, I don't know, dark shade of green, or it's a black background, so maybe a particularly light shade of green. Here you can see the RGB values right here. You can just copy those RGB values, and you could just use them directly. There's no reason. There's nothing in the language itself preventing you from using those numbers directly as an argument like this here. But it will just be easier to read your code, and it'll be easier to remember what's what if you just figure out the RGB values in advance, and you could say maybe like light green. And then use the RGB values from that. I don't even know if I'm going to use that color, but if I want to, I have it. So I'm going to fill my screen with black. And then kind of skipping ahead a little bit, really, but just for the sake of quitting gracefully, I'm actually going to set up my event handling. So one of the things Pygame handles is events, like sensing events, like key presses and mouse movement and things like that. So I'm going to set up a for loop for event in pygame.event.get, which is just a list of events that Pygame is going to return whenever this is called, and this is going to be called every time this while loop runs. This while loop is just going to be running constantly. So it's always every iteration through the loop. It's checking. It's checking every single event that might turn up in this event.get. So if it senses a key press event, or in this case a quit event, that's what I'm going to set up here, you can respond to that somehow. Why I'm setting up the quit event right now, because when I just test out even the most basic thing, like does the screen pop up or not, I want my program to be able to quit gracefully. Just force quitting it sometimes can lag. So having a graceful way to quit is something that's worth setting up at the very beginning. So I'm going to say if event.type equals all caps quit, call pygame.quit and sys.exit. exit. This is just going to gracefully quit all of the processes that Pygame is running, and then have the system, the operating system, end this process, the Python processes that you're running as well. So they'll quit gracefully. It won't lag. It won't hang up, which is much better in the long run as you are testing this. A few other things to add before we can even test this out. I'm just going to put a little, I'm going to put a comment here just to mark. This is where I'll be doing sort of updates. I'll be updating things. And then after you update things, you should draw them to the screen. So this is kind of, once we actually get to building the bulk of the program, this is where most of it's going to, this is where a lot of it's going to happen. A lot of the most important Pygame functions will happen in here, where first you update objects, and then after you've updated the objects, you draw them onto the screen. And just the game does that repeatedly over and over again, and it just until you quit. Things that could cause updates might be events. They might just be calling methods that are built into objects that you create, and then drawing them onto the screen happens after you update them, so that, for example, if you moved an object, you can then draw it in its new location. But before we can do any of that, at the end, and I'm going to have to do this right now as well, just making sure that everything is all set up just to even get the screen on the, just get the screen to show up. I'm going to pygame.display.flip. Flipping the display just it draws the, it sets the display to the most up-to-date version of the display. So after you've updated the locations of the objects and then drawn the new objects, it puts those things on the screen. And then FPS clock dot tick takes FPS as an argument, which is this variable here. And at this point, I think you should be good to just make sure the screen shows up. That's all this thing can do right now. There is no game. All it is a black screen. So you can click run module. It's going to ask you to save. I'll call mine Pong example. And you can see all I've got is a Pygame window. That's all you really need right now. And that's all it should be happening right now. It's just proof that the window shows up. And if you click the X, it should quit gracefully. It shouldn't crash out. All right, so now let's start actually adding game components to the game. What will this game need to have? Well, it's going to need to have a paddle and a ball. So I'm going to first set up the paddle and the movement for the paddle. I want the paddle to be defined as a class. And my paddle class is going to take for arguments its initial x, y, and y positions, and its width and its height. And I'll just set those instance attributes to those arguments. It also needs to have a couple other attributes that I don't need arguments for. I mean, I guess I could have argument. Well, I don't feel like I'm going to need them. I could, but I think speed can just start at 0 because it doesn't need to be, the paddle doesn't need to be going anywhere when it's if it hasn't been given any instructions to go anywhere. And I could set its color here, or I could just set the color when I draw it. So sort of a, yeah, I'm not going to set the color here. I'll just set the color when I draw the rectangle onto the screen. And then I know it's going to need to be able to move somehow. And when it moves, it's only going to, you saw my example, it was just a single paddle along the bottom of the screen. So I only need to change it according to its x, along the x-axis. So I'll do self.x plus equals self.speed. And I don't even need to set a y speed because it's only moving along the x-axis. All right, and so in order to actually use this this paddle, I'll need to create an instance of it. I only have one paddle, so I'm just going to call it paddle. If you had multiple paddles, if you were setting up a 2-player game, you could say paddle 1 and paddle 2, 2 different instances of the paddle object, but I'm just going to demonstrate one. It's going to be an instance of paddle, and remember, it needs to, I want to identify its starting x value and y value, which I'll just say are screen width times 0.5. So it's just going to be centered. It'll be in the center of the screen, and as far relative to the screen's width, and then it's going to be for the height, for the y, screen height times, I'll say 0.9. And you might be thinking, if you're not too familiar with XY coordinates in most user interfaces, including Pygame games and really most gaming and most computer applications, is that the y-axis is inverted. So let me just show you what I mean by that. Pygame x, y. Do a quick image search. Here's a good example of what I mean by that. You can see in Pygame the origin 0, 0 is in the top left. It's in the top left corner. This doesn't really have much of an effect on what you might think of and how you might approach the x-axis. The x-axis is increases as you go to the right and decreases as you go to the left, which is probably what you're used to. What you might not be used to is that the y-axis increases as you go down. So it's not. It's kind of like the fourth quadrant, except the numbers are not negative. So yes, the negative numbers increase as you go down, but you don't use negative numbers. So you use positive numbers increasing as you go down. that might be something you're not really accustomed to. So when I say screen height times 0.9, that's actually close to the bottom, right? The full screen height, which I set to 480, the 480 is actually the bottom of the screen, not the top of the screen. The top of the screen is 0. The bottom of the screen is 480. So screen height times 0.9 would be close to 480. It's going to be just a little bit off the bottom of the screen. Then I'm also going to set the width and height of my paddle. I want it to be kind of narrow, so I'll say 80 pixels wide and 10 pixels tall. Okay, now this is where we're going to skip ahead to the update part of the loop. So inside the while loop, right? This, by the way, sorry, before I jump back into the while loop, creating your instance of paddle should be happening outside the while loop. Right? Defining things, creating instances of objects that you want to use inside, that you want to use repeatedly inside the loop. You have to define these things and create these instances outside the loop. So create, define the class paddle outside the loop, create an instance of paddle outside the loop. The only reason you would be creating an instance of something inside the loop is if you want to create a completely new object, which we will do. We will actually create new objects, different objects, not paddle object inside the loop. But we want to keep using the same paddle object. Because really it's really just an organization tool for us right now. It's just organizing all of this information so that later you can say paddle.x, paddle.y. We're not creating, at least in this case, we're not even creating a second paddle, so we're not even creating a second instance. So really we can just have the one paddle, and we don't need to create more instances, so you don't want to be doing this inside the loop. So now back when we do go inside the loop, what we do need to do is update the locations of things and update some Pygame objects so that we can draw them onto the screen. So things that need to be done in this section of the code. One is actually just creating a Pygame object that will actually be drawn onto the screen. So I'm going to create a variable called paddle rect or paddle rectangle, and it's going to get a Pygame dot rect object. I'm going to pass it the paddle x, paddle y, paddle width, paddle height as arguments. And this is just Pygame needs, when it draws, the paddle is going to be a rectangle, and when Pygame draws things, it needs to draw Pygame objects onto the screen. So whatever you have, whether you're bringing outside image resources in, or you're just drawing with Pygame's built-in drawing functions like we're doing, you do need to provide Pygame objects for it to draw. So this is one of them, a Pygame rectangle object. And then in my draw code, I'm going to pygame.draw.rect. It needs a destination, like a surface destination surface. You can see I'm being prompted here for arguments to pass. It needs the surface that I'm going to draw the rectangle onto, which is the screen. It needs a color. I defined that light green. Why not use it? Light green. And it needs a rectangle that it's going to draw, which is the paddle underscore rect. And that that should take care of everything that I need to do to just put that on the screen. I'm going to save. Control S saved. If you don't, it's just going to force you when you click run. And you can see I have a light green rectangle at the bottom of the screen. I can't do anything with it yet, but it's there. Okay. Now to get it to move, I'm going to need some event handling, and I'm going to call that move method that I defined. So let's take care of some event handling. The events that we'll be controlling it with will be key events. So I'm going to say if event.type equals key down. This does not, by the way, this does not mean the down arrow key. This is if a key is pressed down, all key down events will go under here. So all keys being pressed down. So if event.key equals k underscore left. Now these are all, by the way, these uppercase, note the uppercase convention that I mentioned. These are constants. So these are by convention things that you should not be changing are just all caps. It's an indication to the programmer that whoever wrote this Pygame library is saying, don't mess around with these values. They're constants. So yeah, if you just like, for example, if you start messing around with the RGB values stored in black, it's going to break using this as a black color because it won't be black anymore if you turn it green. If you start messing around with the values of quit or key down or k left, they won't be functional as whatever they are. This is all abstracted away. Well, we don't really see the implementation of Pygame's key event handling, and we don't need to see the implementation of Pygame's key handling. Just don't go messing around. Don't go changing the values of key down and k underscore left and all that, because Pygame is setting them. You just need to use them. So if the event is the left key was pressed down, paddle.speed will be a negative number because it needs to move to the left along the x-axis. If event.key equals k underscore right, we're going to set paddle.speed to a positive number. So for setting paddle.speed, down in the update code, what we could do is call paddle.move. Paddle.move is going to change paddle.x according to its speed, which now could potentially be set by a key event. So if a key event happens, that's going to set the speed, and then paddle.move will actually update paddle.x, which will then be set in the next iteration. It is after the rectangle object is defined. It'll be set for the next iteration. The iterations happen so fast you won't even see the difference. You will notice later that these things are happening in a sequence. They're happening in order, and the order is not always you're not always necessarily going to be able to set, for example, set something immediately before you use it. We could change the order of this. I could put paddle.move up in front, but then later there are other things that we'll need to set where they need to come after paddle.move. And so in the end, the sequence matters, but it doesn't matter that much because these updates are happening so many times per second. You'll see the outcome. You'll see the outcome anyway. Like it'll happen very quickly. So paddle.move is going to be called, and that should update the location of the paddle. So let's try it out. I'm going to Control S, save, run. And now I should be able to use the left and right keys to move my paddle. However, my paddle is kind of locked into a left or right position and it doesn't stop. If you tap the keys, it will keep moving. So that's because all the code does is sense a key down event. That is a key being pressed down. However, we also need to sense key up events. Key if event dot type equals key up, and event dot key equals the same keys that we've used before. In fact, I mean, you could just copy all of this code. It's just k left and k right again. But this time, for the key up event, set the speed to 0. It's the same. It's sensing the exact same keys that it sensed being pressed down. It's sensing when they're being released. So when the key is released, it's going to set the speed back to 0. So now, if you save and run, you should be able to press the left key or the right key, and the paddle should stop moving. Okay, so we've got a functional paddle. It moves around. Next thing to set up is going to be the ball. So you've kind of already seen an example of defining a class and then using that class. We're just going to do the exact same thing with the ball. Define a class, and a lot of the ball has a lot more complex. There are a lot more complexities to what the ball needs to be able to do. But to start with, a lot of it's the same as the paddle. Everything that's being drawn onto the screen needs an X, Y, width, and height. The ball isn't any different. And the ball also needs a speed variable, the speed instance attribute. However, I'm going to define an X speed and a Y speed separately. And that's because the ball can move in all directions. It isn't just locked to the x-axis the way the paddle is. It needs to change. It needs to go up and down. It needs to go left and right. I'm going to set the initial x speed to 4, and I'll set the initial y speed to 4. And it will also need a move method. And the move method for this will start to get kind of complicated because there are a lot of things it needs to be able to do while it's moving. But for now, let's just get proof of concept and make it move at all. And while it's moving, it will also eventually need to be able to sense the edges and the paddle and bounce off of them. But for now, let's just say self.x plus equals self.x speed and self.y plus equals self.y speed. Just basic movement for now. Let's create an instance of ball. And where do I want to put the ball at the beginning? That's just for now. I might end up moving it, but I'll start the ball in the top left corner, just to see it move. Might end up starting it somewhere else, but for now I'm going to start it in the top left corner, and it should be fairly small. I'm going to make it 10 pixels by 10 pixels. And then in my update code, I need to create a ball. My ball is not a circle, it's a rectangle. The reason I'm doing rectangles for both is just that Pygame's collision detection is easy to work with rectangles. So I'm just trying to keep this as simple as possible. So I'm going to make the ball a rectangle as well. Pass it the x, y, width, and height. And call ball.move. Down in my draw code, I'll draw to the screen another light green rectangle. My ball rect area. I think that's everything I should need for now, just to make the ball show up. I'll run this, and you see there's a ball, it moves, and it goes right through my paddle. It does move, but it doesn't bounce off anything. So that's the next thing I should really set up, is getting the ball to bounce off of things. And that is where I mentioned before, the ball move method is going to be a little more complex because its motion needs to be able to take a lot more things into account, like did it run into an edge? Did it run into a paddle? That kind of thing. So first let's set up bouncing off edges. That's going to just be a series of if statements that check to see if it ran into what it ran into. So, check to see what its x and y positions are and if they sort of reached a limit. So if self.x is greater than or equal to screen width or self.x is less than or equal to 0, let's set self.x speed to itself, or I can multiply it by -1, or I can just say negative x speed. That'll work fine. And then if self.y is greater than or equal to. So the greater than or equal to thing is weird. I'm going to set this up so it bounces for now, but I will eventually need to set it up so that something different happens for the greater than or equal to. If the ball reaches the bottom of the screen, the way I'm setting up the game right now, it should actually just be game over. But for now, I'm going to set it up to bounce just so something happens. I don't have a game over. I don't have a game over function yet. I suppose I could just define one, but there's more stuff to add, and I don't have. It'll just always be game over because I don't have the ball bouncing off the paddle yet. Let's just make the ball bounce off the edges for now. So if self.y greater than or equal to screen height or self.y is less than or equal to 0, self.y speed equals negative self.y speed. And I just noticed an error up here. Make sure you don't do what I did and leave out the self dot for the x speed. So you need to be self.x speed and self.y speed. Okay, so if x reaches either the right edge of the screen, the full width, or 0. The reason I don't use equal. The reason I don't use an equal sign here, I use the greater than or equal to or less than or equal to signs, is that as the ball starts moving diagonally, that will change exactly what it might change exactly what x, and as the ball starts moving faster, as the speed starts to increase, and as it's moving diagonally in a bunch of different directions, it might not be reaching the exact same x or y position all the time. If it might not exactly reach, for example, 0 on the left, it might exceed 0 just for a little bit before it turns around. So I want to set this to catch any of those, just in case. So this should handle bouncing off the edges for now. But it's currently stuck in a corner. Let me move it out. Let me move it out of the corner. Where I defined so where I created the instance. Is that where it was? Or was it starting? Yeah, it was where I created the instance of ball. I put it all the way in the top corner. Let me put it almost in the top corner. We'll change that 0, 0 to 10, 10. Okay, so we've got a moving ball. It's bouncing off of the edges. You'll notice that on the bottom and on the right, it kind of goes through the edge. That's because Pygame uses the upper left corner of an object to define its x and y. So it's sort of the 0, 0 point of the object itself is the top left. So when it's sensing, did the ball reach x equals 0? That's like the left side. The left edge of the ball does line up with that edge. Nice. Let's see if I can get you a nice resource to see that. Game. you can kind of see it in this diagram. X and Y are measured from the upper left corner of the rectangle. That means when this rectangle collides, if you're sensing whether or not it collided with the left edge, the actual left edge of the rectangle will match up with the left edge of the screen. However, when you're sensing to see if it collided with the right edge of this green rectangle will go all the way over the edge of the screen before this upper left corner ever reaches it. So it's going to cross over first before it ever senses that collision. So what I'm going to do to take care of that problem is that if self.x is greater than or equal to screen width, I'm going to say if it's greater than or equal to screen width minus self.width. So the minus self.width just takes care of the fact that along the x-axis there's an extra width, the entire width of the rectangle, before you ever there's an extra width all the way to the right. The entire right side of the rectangle, the entire width of the rectangle is to the right of the point self.x. Like self.x is the upper left corner. The whole rectangle is to the right of that. So the whole rectangle should be subtracted away. The whole width of the rectangle should be subtracted away if you want to account for that extra bit and have it bounce off exactly when it hits the edge. Because it was crossing on the right side, it was crossing over before. That should take care of that. And then it really kind of doesn't matter on the bottom because we're just going to change this Y code later anyway. So I'm not even going to worry about that. But you can at least see on the right side, the ball is bouncing off. The ball's bouncing off the right edge. It's still going through the bottom edge a little bit, but that's not going to matter because that code is going to change anyway. Okay, just a couple things to take care of. One is bouncing off the paddle. To do that, it needs to sense collisions with another rectangle. So if ball, so here's a problem that we're running into is we're going to need access to another object. So it's actually going to we need access to the ball rectangle object. So I'm going to add some new parameters here. Ball rect and paddle rect. The paddle object itself doesn't control the Pygame objects, ball rect and paddle rect. These are the Pygame objects that are actually being drawn to the screen, not the objects we define to simply track their x, y, width, and height, and to store their methods that are modifying x, y, width, and height. This is handling all the data manipulation, but Pygame is actually drawing these things to the screen, and it turns out Pygame actually needs these rectangle and paddle objects as well to use its built-in collision detection, which is very convenient. So we don't have to create a collision detection method, but we do need to pass those objects. So these need to be arguments here, and then when creating an instance, or sorry, not when creating an instance, when calling ball.move, let's say ball. What order did I put that in? Ball rect and paddle rect. So ball rect and paddle rect have to be passed as arguments. And then what I'll do here is if ball rect dot collide rect. That is just a method associated with the Pygame rectangle object ball rect. It can sense collisions with other Pygame rectangle objects. So the other object I'm sensing is paddle rect. So if there's a collision, so if that is true, this just returns a Boolean, true or false. Just did this collide with this? If that's true, we want the ball to bounce. So I'll say self dot y speed equals negative y speed and I'll need to somehow also take care of the x speed. The thing with the x speed is that it's not quite as simple. If there's a collision along the x-axis, or if there's a collision, there's no the axis doesn't matter. But if there's a collision with the paddle in particular, the paddle when the ball hits the paddle, the y just always needs to go in the opposite direction. And actually, so maybe we don't need to mess around with x at all, because if x is going, if it's going to be a mirror image, if it's going from left to right, when it hits the paddle, it's still going to be going to left to right. And if it's going from right to left, when it hits the paddle, it's still going to be going from right to left. So I'm just going to leave that the way it is. I'm not going to mess around with the x at all, because it's not necessary. The ball needs to turn around when it bounces off. The ball needs to turn around and bounce up after it hits the paddle, but it doesn't need to change what direction it's going along the x-axis. So I'm not doing anything with the x. All right, so let's test this out now. Might have an error here. Y speed isn't, forgot the self dot. Self dot. Right, so it's bouncing. It might be going through a little bit, it seemed like. Sometimes, if you want to account for that, just like last, well, maybe not. No, because we're using collide rect, so I don't think I couldn't actually tell if it was always sensing it right away, or if it was maybe going through a little bit, but it didn't look bad. So at this point, I'm going to pause. We have a decent amount of the game done. We just need to add some scorekeeping, a way to end the game, and maybe make the ball speed up so that it's a little bit, the game gets harder over time. So that will be in part 2.